Okay, so we're going to try to actually construct one of these rotation shapes in Mathematica using region plot 3D. So what I'm going to do, what we'll make is the region sine x from 0 to pi rotated around the x-axis.
All right.
Okay, so what are my bounds going to be? So what's the first thing, first boundaries I need to say for region plot?
So sine x, I guess, is a boundary. X, or we do it, well, we're going to do planes. So I guess like the line x equal, or the line, yeah, x equals pi is a boundary.
Okay, do I want x to be bigger than pi or less than pi?
We want x to be less than pi.
So x is less than pi, okay. And what's my lower bound for x?
Greater than 0.
X is greater than 0. Okay, so those are my x boundaries. And now the trickier part. What do the slices of this look like when I slice y equals sine x going around the x-axis?
They're gonna be circles.
Okay.
It's gonna start small and then get bigger and get smaller and then get bigger and then get smaller.
Yeah, we have to figure out the equation of those circles. So at a random point x, what's the radius of the circle going to be?
Sine x. Or I guess absolute value of sine x.
Well, we're going 0 to pi.
Okay, so yeah, just sine x then.
Okay. And so what is the equation of that circle going to be?
So we want to, so it's pi times sine x squared, sine squared x.
No, that's the area of
Yeah.
it, but now we're trying to figure out the equation of that circle.
So this is going to be in the YZ plane then?
Well, it's going to certainly be in a plane parallel to the YZ axis.
Yeah.
So you're right, it's
So-
only y and z are varying.
So maybe y squared plus z squared equals sine x? Or sine at that point?
Almost. Y squared plus z squared equals...
Sine of...
It relates to sine of x. What's the radius of the circle?
Radius of the circle is sine x.
Okay, so we have y squared plus z squared equals what?
Is sine squared x.
Sine squared. Actually, what we want it to be is less than, because we want to capture the whole circle. Sine of x squared. And so x goes from 0 to pi, so I'll go minus 1 to 4, so we capture all the x. The y and z will be between minus 1 and 1, but I want it to be 5 long, so I'll go minus 2.5 to 5. Am I still on screen, by the way?
Yes.
Z goes from minus 2.5 to 2.5, and the only reason I'm doing that is to make it undistorted. Plot points. Let's just do 100 at the beginning. So what do you think this is going to look like?
I think it's going to be like... It's going to look like sine x when you look at it straight on.
Okay.
But then maybe it's going to... It may just be like this hump shape. Like maybe full hump. Like 2 humps. Yeah, like, I was thinking kind of like that. It's like almost like an eye shape.
All right, here, play around with it.
See, when you look at it, I guess right on, it's this top part. The sine x, but then we rotated it all the way around.
Yeah. It's pretty neat to see that shape. And so we'll 3D print this overnight. And so maybe we'll take a look at it in the morning.
Alright.
But the interesting thing about this also is what's the volume? We'll let Mathematica do the volume for us. If I wanted to set up a volume formula, what would it be?
So you have, it's the pi times sine x, or pi times, I guess, the integral of sine x squared evaluated at it's 0 to pi.
Yeah. Sorry, integrate. So there we go. Whoop, off screen. So the volume is what?
Pi squared over 2. So the volume of our... That's pretty interesting.
The volume of our shape here is pi squared over 2. Do you know? Could you have done that integral? Do you know how to integrate sine squared?
It's not easy, but I think I probably could have.
Alright, what do you think you do?
Like, you have to use an identity for cosine of 2x, which is 1 minus sine squared x, and then you can fiddle with that to create an identity. Some identity for sine x.
Yeah, cosine of 2x is cosine squared minus sine squared.
Mm-hmm.
And then you play around with that. Yeah, you're right.
But it's easier for odd powers of sine because you can do the u substitution a bit easier.
Yeah, there's a trick. It's actually pretty cool. Anyway, this is neat. So we'll 3D print this overnight, and then we'll play around with it a little bit tomorrow, just for fun.
Okay.
All right, good job.